Okay, class, my goal is to try and do some videos to help us understand some of the concepts in the book. I want to make them quick. You guys are able to pause and fast forward and do all that kind of stuff, so hopefully if there's something you didn't understand, you can slow it down and watch it again. So let's talk about what statistics are. Statistics are planning some kind of study, in a way, taking that data and interpreting it in a way that's meaningful, okay? So through a study, hopefully you're collecting data. Now, there are different types of studies. We'll talk about those kind of studies, but you're trying to find data about a specific theme, okay? Now, data is the information you gain, okay? A population is part of a study. A population is all the people that fit into the category of what you're trying to study. So if you're trying to study the number of illegal immigrants in the United States, then anyone who's an illegal immigrant would qualify in that category. Or maybe you're trying to study the number of professors at Diné College. All the professors at Diné College would be in that population. A census is a little bit different. A census is where you take every single person within a population and you study them, or you find out about their information. The U.S. government does a census every 10 years, I think it is. And in that census, they go around home to home and talk to every person, and so they can talk to everybody. A sample is just talking about a small portion of the population. So if you were to take the professors at Diné College, you would probably not talk to every single professor, but you would talk to a sample size of those professors. So maybe 10 of them, or depends on how many professors there are at the college. Okay? So, examples of statistics. A Gallup poll showed that 66% of respondents worried about identity theft frequently or occasionally. That's a statistic. Political polls, they're all over the place right now. Those are statistics. School ratings. Some of the schools you guys are around, you might know what their ratings are. I see signs at the schools here all the time, they're A-rated, so that's a statistic. Car safety. If you watch any car commercial, they always throw up their safety statistics. So, processes for conducting a statistical study. First thing you have to do is prepare. Now, while you're preparing, you need to consider the context of the information you want to gather. So, what is the data you want, and what is the goal that you have for your study? What is it you're trying to accomplish? You also want to take a close look at the source of your data. Is the source reliable? So studies are not always necessarily like you're taking people into a room and you're having them do a certain thing. Studies can be research that you do based off of historical facts or something like that. So you have to make sure that the information you're using is accurate and it's trustworthy, okay? Was it bias? Now, bias is one of those words. Did the person put their own thoughts and their own beliefs into interpreting the data? That's something that's going to be difficult for anyone who's doing a study to do, is to eliminate that bias. If you're religious, you might look at certain information one way, and if you're atheist, you'd look at it another way. And so, depending on what your beliefs are and your value systems, those are heavily influencing your interpretation of data, and so you have to try and learn to keep that out of studies. We're going to be doing a study for your final, and it's a minor study, it won't be anything huge, but you'll have to try and figure out how to do that, okay? You'll have to consider the sampling method. How are you going to collect your data? Is it through surveys? Is it through observations? Is it through questionnaires? Is it through interviews, okay? How are you going to collect your data? Now, the next thing is you also want to be able to analyze the data, okay? So once you have data, you're going to need to be able to analyze it. Ways of doing that is graphing the data, and we'll talk about graphing the data. You'll explore the data. When you're exploring it, you're looking for what we call outliers. Outliers, whatever word you want to use, it's the same word. Those are numbers that are too big or too little to fit in with the rest of the information. Outliers are a big thing. For example, when they say the average wage of a person within this community is $70,000 a year, but really most people are living off $30,000, but there's a couple millionaires in there. That throws off the average, and so that's an outlier. They're too big, they make way too much money compared to the rest of the people, and so they throw off the average. You have to look for missing data. Sometimes people don't want to respond, and so that affects the result. If people refuse to respond to your survey or whatever, then it's not legitimate. Other missing data are, there's lots of ways that data could be missing, sometimes through human error or whatever it might be. Also, did you apply statistical methods using technology like the internet or research or something like that? And then the final step to doing a study is to conclude. Do the results that you have statistical value to them? Okay? Are they significant? So you're going to be looking at whether or not your results actually are truly results. And do they really show what the population thinks and believes? All right, next, we want to know how to analyze the data. So we have to, as we analyze data, we have to be able to look for what we call the pitfalls, okay? Now the pitfalls that we might come across are misleading conclusions. Now, I'm going to tell you right now, whatever your political beliefs might be or whatever your thought process might be, the media is one of the ways that we see misleading information daily. They have an agenda. If you don't think they have an agenda, pay really close attention to it, do your research, and look at what they're spending their time talking about and how they're focusing their attentions. The media is very, very biased, guys, and so that would be an example. For example, now whether you believe this or not, but according to the media, guns kill people, not people killing people, right? Criminals are victims, right? That's what the media is trying to tell us. Things like that. And so you have to be aware of those biases and that misleading information that comes from whatever source it might be coming from. In statistical analysis, we need to make statements that are clear so that even people that do not have statistical backgrounds can understand the information. And so that's one of your goals as well. Make the information clear and understandable. When you report results, it's better to take the measurements yourself. Now what that means is this, guys. If you were to really take people and you wanted to find the average weight of an American citizen, and you just ask them, what's your weight? We're going to have a whole country of people that are perfectly slim and slender and look amazing. Do you know what I mean? They're not going to give you your true weight. They're going to fudge it a little bit. And so it's best always to take your own measurements when possible. Small samples is another issue you have to look at. Sometimes your sample is just too small for what you're really looking for. So the population is 1 billion people and you only interviewed 10 people. That's not a sample size compared to the overall population. And so if you have too small a sample, then it's not going to be accurate information. Loaded questions. Now most of you with your own study that you're going to do for me, you're going to have to put together a survey. And in that survey, you're going to have situations where you might accidentally have loaded questions. So here's how this works. The questions and surveys can be need to be worded carefully. Questions cannot lead the person to answer the way that you want them to answer. For example, if they're a customer and all you put on there was, how was your experience? Good, great, or excellent. But you didn't give them the option to say terrible or whatever it might be, that's not an accurate survey because you are forcing them to answer the way that you want them to answer, okay? Questions that make people feel uncomfortable, maybe their sexuality or things like that. Those are tough questions to put on a survey because you got to leave out anything that might make someone feel compelled to answer in a certain way or worry about judgment, and so they won't give you a truthful answer. Okay, so that's one thing about your surveys. Now, the order of questions also matter. For example, if you were to take a question like, does traffic or industry cause pollution? and then reword it as, does industry or traffic cause pollution, people are going to answer differently to each of those questions because of the way it's worded. And so on the first one, since you said traffic first, they're probably going to blame traffic. And then on the second question, since you said industry first, they'll blame industry. People think that way. I do it to my kids all the time. When I want them to answer a certain way, I'll word my question in a way that they remember the last thing I said, you know, that type of thing. And that's what you have to avoid when you're doing a study. Non-responses are definitely an issue, so you need to be aware of those. People, you're going to ask people to do your study, and they're going to say no. And that does affect your results. I don't ever answer the McDonald's studies or their questionnaires. I don't ever answer when I do something online and they send me those surveys. I don't do those. And so they don't have complete results, and they don't have enough the information that they're looking for completely. Now, that doesn't mean the data is completely false. It just means that you're missing some of the data, and so that could change a little bit of the information you have. Missing data, someone drops out of the study or they didn't respond, that would be missing data. Precise numbers, so if you gave a number like 847,565,000 people went to the fair, that's a high number, I know, but if you gave that number and it was really an approximation but you just said the number, then people believe that that's the actual number when really it was an approximation. So that's a misleading number, okay? That's what we call a precise number. You gave a precise number when the number was not precise. And then percentages. Percentages can be very unclear. For example, we have a 95% approval rating. Have you guys ever heard something like that? Who's the one giving them this approval? And approval rating compared to what, you know? You have to be able to analyze these studies, analyze the statistics, and know whether or not it's legitimate, okay? So stuff like that can be misleading. 95% of what? Okay, so now we need to be able to find percents. I'm going to come over here and zoom in on the board a little bit better. So, give me just 1 second. This is the best I can do for you guys right now, sorry. So, percent of an amount. We want to find 6% of 1,200. So the way we find that is we're going to change 6%, excuse me, we're going to change 6% to a decimal and multiply it by 1,200. So when we change it to a decimal, the decimal is behind the number right here. And to change it to a decimal, we move it twice to the left, making this 0.06 times 1,200. Now when we plug that into the calculator, we get 72. So that is 6% of 1,200 is 72. Okay? Fraction to a percent. When we change a fraction to a percent, let's say we have 3/4. What we do is we divide the top number by the bottom number. So the top number goes in the box, right? If you're doing division. In your calculator, what you're going to do is you're going to hit the 3 first, hit the divide button, and then hit 4. So when you do that, you get 0.75. That's a decimal answer that you get when you divide. So we need to move the decimal twice to the right now to make it a percent. Moving it twice to the right makes this 75%. So changing a fraction to a percent is done that way. Okay. Next, it's my high quality board here. Decimal to percent. Hopefully you guys can see this just fine. A decimal to a percent, if I have 0.25, I kind of just did this, but this is my decimal. I move the decimal twice to the right to change a decimal to a percent, and this is 25%. Percent to decimal, we've already kind of done this as well. Changing a percent to decimal, if I have 88%, the decimal's at the end of the 8, we move it twice to the left, so just the opposite of each other, and this becomes 0.88. So that's our percent to a decimal, and that's how we change those, okay? Now, in a Gallup poll, 1,018 people in this Gallup poll. Okay, in a Gallup poll of 1,018 adults, 39% believe in evolution. So what is the exact number that believe in evolution? Well, what we do is we want 39% of 1,018. We change the percent to a decimal always, because anytime you use math, you can't do a percent to solve a math problem, so you always change it to a decimal. This will be 0.39 as a decimal times 1018. 0.39 times 1018 is 397.02. And so that represents, so since this is, what's the exact number that believe in evolution? You can't have a 0.02 person. And so the answer here would be 397 people out of 1,018 people believe in evolution. Okay? 255 people said they did not believe. If that many said they don't believe, it wants to know what percentage of those people didn't believe then. So the way we do that is we're going to take 255, and divide it by the total amount, which is 1,018. And that will give me a decimal answer. So 255 divided by 1,018 is 0.25049. Now guys, to change it to a percent, I'm going to move the decimal twice to the right. This becomes 25.05%. 25.05% do not believe in evolution. Okay? And so that's how that works. All right. So now there are different types of data. First off, we need to understand what makes data. Give me 1 second to zoom back out. So some of the verbiage. First off, a parameter. So that's a numerical measure describing a characteristic of a population. Now this is the population is an actual number of the population, okay? So parameters are dealing with actual numbers. So there are some times that you can get all the numbers. If there's 5 employees at a certain business, you can study all 5 of those employees, and so you have an actual parameter. A statistic is a numeric measure of a sample. So that's when your numbers are too big for you to study everybody, and so you use a statistic, okay? So it's a sample size. So we use population parameter to help us identify that we know the actual whole population's values. And we use sample statistic to help us identify that we're just, for statistics, we're using samples, okay? Here's another example. In a Harris poll, 2,320 adults in the United States were surveyed about body piercings, and 5% of respondents had a body piercing, but not on the face. At the time, there were 241,472,385 adults in the U.S. So let's discuss what the parameters and statistics are. A parameter would be the 241,472,385 adults. That's a parameter because that represents the entire population. A statistic would be, for example, 2,320 adults, because that's a sample size, and 5% of respondents. That would be a statistic, okay? So that's what represents the statistics. Parameters represent the whole population. All right. Now there are different types of data. There's quantitative data, which consists of numbers, like ages of the respondents. Quantitative is purely numbers, okay? Dealing with numbers. This is information you gain where it is number values. When you have number values, you need to pay attention to the units. For example, feet, minutes, seconds, whatever it might be. You need to pay attention to those units whenever you have quantitative data. Categorical data or qualitative data, this is data that uses labels or names. Now you guys have already looked into some of this, so this shouldn't be new to you. These can be coded to give you numbers, but those numbers still represent the names, and so those numbers are not really representing the data. For example, you could do what political party you affiliated to. You could give a 1 for Democrat, 2 for Republican, 3 for Libertarian, and so forth. Those numbers would represent the word Democrat, Republican, or Libertarian. The number of players on a jersey. The number on a jersey for a player, that number represents the name of the player. So that number isn't a legitimate numerical value, it's categorical, okay? Now, there's other types of data. There's discrete data. This is when you have a finite number in the study, okay? It's countable, I guess is what you'd say. So the number of dates you went on this week. 0 is a really easy number to use, isn't it, guys? Just kidding. Anyway, or you can use infinite values if you're looking at just a certain section of that infinite numbers. So for example, you're flipping a coin, you can flip a coin an infinite amount of times, but if you were to look at how many times you flipped heads before you flip a tails, that would be a section of numbers, and then you could use discrete data, or call it discrete data. However, discrete data is finite, okay? Continuous data just means the data continues on forever, okay? So there's no end to it. So an example of this would be like the number of soda bottles that are produced with a manufacturer. Those things are just continually running through. There's no way to have a finite number there, although you could look at within a day or within a certain amount of time frame, and that would make it more finite. However, the production of those bottles is continuous, okay? All right, next thing for types of data, we're going into levels of measurement. Now there's different levels of measurement. The first one is nominal. This is categorical, okay, meaning that it has labels and everything like that. These would be things like your social security number, which represents you, your name, and yes, no, or undecided answers on a survey. Maybe your eye color. Those would be nominal data. Ordinal data would be things that you can put into order. So age groups, things like that. Grades, ranks, those are all ordinal. Interval data, these are, they can do all this, the previous stuff, but there's a value to the difference between the data. So for example, temperature in years. 90 degrees and 60 degrees, there's a value between those two numbers, 90 to 60, it's a big value. Ratio has order, the difference has meaning 90 to 60, that has meaning, and it has a 0 starting point. So car lengths or lengths of classes. Anytime you're talking about height, lengths, or volumes, we're talking about ratios, okay? Ratios, that's another word for fractions. And that's pretty much the different types of data that we have, all right? And that ends this section.